is Brian Albright. I'm the editorial director at Digital Engineering Magazine. Welcome to the DE 24/7 podcast. Today, we're talking about digital threads, what they look like in practice, why they're still challenging for so many organizations, and how manufacturers and engineering teams can connect to product data across the life cycle in a more sustainable way. And my guest today is Jonathan Scott from Razorleaf. Jonathan, welcome to the show.
Thanks, Brian. Great to be here.
All right, and I should mention, you're not just a guest today, you're also a podcast co-host yourself. You co-host
Right?
Stay Sharp and Digital Engineering. So you're very much on the other side of the mic today.
That's right. Yeah, I'm usually asking the questions, not answering them. So this should be fun.
Great. All right. Well, we'll try to go easy on you here. If you could, before we dive in, just kind of give us an overview of who you are and what Razorleaf does.
Yeah, absolutely. I'm Jonathan Scott. I'm with Razorleaf, and for those just listening, that's two words, razor and leaf smashed together. My background and education are in mechanical engineering and systems engineering, but I've been doing consulting in the digital space for 25 years now. And I'm the chief architect at Razorleaf. And we work with manufacturing and engineering organizations to help them better manage, connect, and leverage product data across the entire product life cycle, right? And Razorleaf's got a long history working with PLM, PDM, and MES systems, and with enterprise system integration. What we've consistently seen is that companies invest heavily in the individual systems, but the data between those systems is still fragmented, and the cross-system processes aren't a whole lot better. So people end up relying on spreadsheets, email, and tribal knowledge to bridge the gaps. So our focus is helping organizations move beyond that by delivering and connecting systems in a way that reflects how the business actually operates. And CLOVER is a direct result of that experience. It's a platform designed to help companies build and maintain a digital thread that supports decision making, collaboration, and long-term scalability. So that's kind of us in a nutshell.
All right. Well, you mentioned fragmentation, and a lot of our readers struggle with that too. Digital threads have been talked about for a long time, but a lot of these organizations have a hard time implementing them. So why is this still such a hard problem to solve?
Yeah, at its core, the challenge comes from the sheer volume and diversity of data involved. Modern engineering and manufacturing organizations create enormous amounts of information, right? Drawings, specifications, bills of material, change records, quality data, service documentation, and all of that data lives in different systems. Most organizations, they start with good intentions. They implement PLM or ERP to bring structure to their processes and to bring some of this data together. But a true digital thread isn't confined to one system. It's a connected flow of data that moves across engineering, manufacturing, quality, supply chain, and service. Where things get difficult is that each function needs that data in a different way. Manufacturing may need a different structure than engineering, like the whole EBOM, MBOM debate, right? Quality might care about traceability, while service cares about configuration and history. That creates complexity, and many teams assume the only way forward is, heavy projects or deep IT involvement. And what we've learned is that digital threads fail when they're treated as these kind of massive one-time projects. They succeed when organizations take a more structured approach, first understanding their data, defining clear use cases, and then building connections incrementally rather than all at once. I mean, you do have to start with the end in mind, to sort of steal the Stephen Covey phrase. But you don't want to point yourself in a corner, right? But you have to start somewhere and build on your successes. I mean, another challenge we see is it comes from trying to use the wrong tool for the job. We've helped plenty of clients get over the hump after they tried to use a general purpose ESB or iPass tool for connecting digital product data, and they got stuck defining and coding this really complex integration logic to do simple transactions like transferring a bomb.
All right. Well, before we go on, can you explain that ESB and iPass? What are those?
Yeah, sorry, you caught me serving up alphabet soup there. So ESB is Enterprise Service Bus, and iPaaS is Integration Platform as a Service. And these are sort of big IT tools. They're good technologies, but they're general purpose tools. And IT departments often are not built for engineering and manufacturing data. Those tools, they really aren't sort of centered on that, and that's where the challenge comes in. They have to spend a lot of time understanding it before they can sort of use those tools to implement a thread.
Okay. All right. Well, let's go back to something you said about addressing that challenge of building digital threads. The idea of building incrementally is interesting. So, based on what you just said, how does Clover help your customers take that structured, manageable approach?
Yeah. So Clover was designed specifically to take friction out of the integration and digital thread process and out of those initiatives. Because instead of relying on what often is, brittle point-to-point integrations, it uses a hub and spoke architecture that allows systems to connect through well-defined interfaces, right? So Clover kind of sits at the middle and it reaches out to each of these systems, and that's one of the differences. Another important aspect is that Clover is low code or no code. So meaning you don't have to have code. If you want some, you can have some, and it is not, you don't have to code the whole thing. So that's what we mean by low or no code. It gives organizations a framework they can configure rather than having to build everything from scratch. And we could talk more about these later, but we call these our digital patterns. And these digital patterns lower the barrier to entry and they really reduce the long-term maintenance risk because that's something that we sustain. Another key point is that Clover's vendor neutral. Most companies operate in a heterogeneous environment, tools from this or that vendor. And those environments, of course, they change over time and at sort of weird intervals. Clover's designed to maintain continuity as systems are updated, replaced, and expanded, which is really critical for sustaining a digital thread over the long term. And I think maybe an example would help really explain what I mean here. So let's say the biggest challenge for a company is to get accurate bombs from PLM into MES and then ultimately into ERP and to connect all three systems so that when an order comes in the future, that product order is ready to flow smoothly when it arrives. So a three system interaction can look pretty daunting when you think about the back and forth flows and the careful orchestration of events, but it doesn't have to be, right? Instead of writing a series of point to point connections and then coding in all of that order of operations logic and testing all of your use cases before going live, you could use the BOM digital pattern in Clover to connect two of the systems, right? And then once that's working, layer on additional steps and add in the third system in kind of a step-by-step manner. And when the timing's right and that first challenge is solved, it's not hard to add in that fourth, fifth, et cetera, system into the thread. So instead of treating integration as a one-off technical exercise, Clover helps organizations think of it as an ongoing capability that evolves with the business.
All right. Well, you've touched a few times on structure and configuration, and you mentioned digital patterns. So can you explain a little bit more about what those are and how they help bridge that gap between technical integration and the business needs of the customer?
Yeah, sure. Digital patterns they're a way of capturing how data behaves in real business processes, right? So they define common data types, say, parts, bombs, change orders, along with their rules and relationships. For example, change order isn't just a record. It has impacted items that it's related to. It has approvals, downstream effects, timing considerations, that kind of thing. So digital patterns encode those pieces of data and those behaviors. So the integrations aren't just moving the data, but they're preserving meaning as that data moves between systems. And what's powerful is that these patterns can be connected visually and through process hierarchies. So teams using Clover can wire together how data flows from one system to another without writing large amounts of custom code. That makes it easier to align integrations with business intent rather than purely technical constraints. And at the same time, the platform remains extensible. I talk about these patterns as if, you just use them like they are. Yes, but you can extend them. So organizations can customize or extend patterns as needed, which is important because no two environments are exactly the same.
Well, that focus on preserving meaning is important. So when organizations get that right, what changes operationally? How does that affect their day-to-day work?
Yeah, when data is connected properly, the impact is immediate. Teams spend far less time searching for information, reconciling discrepancies, or manually re-entering data between systems. And a digital thread provides a unified path to current, consistent information. That improves decision making and it reduces the risk of errors caused by outdated or incomplete data, which of course happens all the time. It also creates opportunities for automation. Tasks that once required significant manual effort can be streamlined or eliminated entirely in some cases. So, from a leadership perspective, this translates into shorter time to market, better data accuracy, improved collaboration across functions. Engineers can focus on solving problems instead of managing data, and organizations become more resilient as their processes can scale.
Well, I think that naturally leads into digital twins, which depend heavily on trustworthy data. So, how does a digital thread support digital twins, especially for these types of complex products?
Yeah, exactly. Right. Digital twins are only as good as the data behind them. They rely on information from multiple systems and they have to be updated continuously throughout the product lifecycle or they're out of date and they're really less useful. So for complex products like aerospace, industrial equipment, highly regulated environments, that data includes thousands of parts, configurations, documents, service records, all those kinds of things. And without a connected digital thread, it's almost impossible to keep everything synchronized and know the right things to use at the right time in your digital twin. So Clover helps by linking those data sources and workflows so digital twins receive timely, accurate information. Engineers, manufacturing teams, service personnel, they can all work from a shared, consistent view of the product, whether they're making design changes, planning maintenance, or monitoring performance. And this level of connectivity, it really turns digital twins from static models that you kind of have to stop and prepare into living assets that support informed decision making across the organization.
Right. Well, you talked a lot about accuracy and consistency, which are also critical for artificial intelligence. As organizations look ahead, how do you see digital threads supporting things like AI and advanced analytics? And we're seeing a lot of this type of activity both with our customer base and also with a lot of the software vendors.
Absolutely, right? We can't have a conversation and not talk about AI today, So AI has tremendous potential in engineering and manufacturing, right? From design optimization to predictive maintenance and decision support, but AI is only effective if it's drawing from accurate, well-connected data. And a digital thread provides that foundation. It ensures that the data is consistent, it's contextualized, and it's traceable across the enterprise. And without that, AI initiatives risk producing insights based on incomplete or misunderstood information. That's even worse, right? So, another way that AI connects to this digital thread topic is in breadth of insight. One of the aspects of AI that people love to talk about, and I think is fascinating, is how AI can look at larger data sets than humans can sort of mentally manage. And then AI can find patterns and insights across that data as a result of this, I'll call it a broader aperture, right? So a constantly expanding digital thread is that broader aperture, right? That it can sort of find these patterns across. So, of course, you could just point AI at all of your disconnected enterprise systems and let AI make assumptions about how that data is connected. But that's dangerous. It's going to lead to hallucinations. So that's what digital threads are for, is making all those connections explicitly across systems and data sets.
Mhm.
And they provide the confidence that insights are grounded in reality, which is especially critical when decisions affect safety, cost, long-term performance, that sort of thing.
Right, right. So, for our listeners here who were thinking this all sounds great, but where do we start? What's your advice?
Yeah, sure. Yeah. That's a fair question, right? I'd say the most effective approach is to start with a clearly defined use case rather than attempting to connect everything at once, right? And to support that, we sort of package Clover to support that kind of activity. It's you can get it in multiple packages, basic through enterprise, and it allows organizations to align the platform with their current needs and their maturity and how they want to proceed. So you can deploy Clover on premise. You can do it in the cloud, in air-gapped environments, or in hybrid configurations of those. And it's designed to coexist with other integration tools that could already be in place, like the ESB and iPaaS systems I mentioned earlier.
Right.
Lots of people can get started just by getting access to Clover, connecting to their endpoints, meaning the systems that they want to tie in, and configuring one or two digital patterns just to start passing data. But Razorleaf also provides consulting and integration planning services to help organizations define and execute their strategy on digital thread if they need more guidance or if they want help getting started. They don't have to have us, but we're there if people want it. And for anybody who wants to just learn more, and that's the next step, the Razorleaf website is the best place to explore Clover in more detail and to see how it supports digital threads and digital twins across the enterprise.
Right. Well, Jonathan, this has been a great conversation. I appreciate you stepping out of the host role for a change.
Yeah, thanks, Brian. I really enjoyed it.
Well, for listeners, please check out Razorleaf's Stay Sharp podcast. If you're working on a digital thread project, reach out and learn more about Clover and how they approach integrations. We're going to have links to all these resources on the landing page for the podcast on our site. Thanks again for being here, Jonathan. And thanks to our listeners for turning into the DE 24/7 podcast. And we'll see you next time.